Welcome to Accelerated Math 106, Module 3.6. Take a look at the relationship between decimal numbers and fractions. So we're always introducing decimal numbers right after introducing fractions. So it turns out every fraction can turn into some sort of decimal numbers, but not every decimal numbers can actually turn into a fraction. All right. So when we are able to turn any fraction, all right, into decimals, okay, we call those the rational numbers. All right. Irrational numbers simply means decimal numbers cannot convert back into a fraction. Okay. So So in this video, in 3.6, in module 3.6, we're going to take a look at how we can convert back and forth between decimal and fractions. So to change from decimal to fraction, a decimal number less than 1 digit or to the right of the decimal point can be written in fraction form by writing a fraction with a numerator that consists of the whole number formed by all digits of the decimal numbers to the right of the decimal point, and the denominator that is the power of 10. So I kind of show y'all this in module 3.1. If we can read our decimal number correctly, we can quickly write them as a mixed number. So if I read this correctly, this is 54 and 792, and a 2 is sitting on the thousands place. So that'll be 792 thousandths. So right away, how we read decimal number is how we will write it out as a mixed number. If my decimal number is greater than 1. So what's saying up here, the procedure is where a decimal number is less than 1. So let me just give you an example. Let's come back to this. So if I have like a 0.5, all right? If I just have a decimal that's less than 1, but like a 0.5, if I read this correctly, this is 5/10. So once I write them as a fraction, so every decimal, see, not every decimal can turn into fraction, okay? But every fraction can become a decimal. So 5/10, reduce that, becomes a half. So most of the students know 0.5 is a half, and that's their relationship. Okay. So what we're saying is what we're saying is 0.5 is equal to 1/2. They're exactly the same thing, just in different form. One is in fraction notation, the other one is in decimal notation. All right. So if I have a decimal number that's greater than 1, we can write them as a mixed number. Since the problem will also allow me to write them as mixed number form, now all I'm going to do is reduce. So look like 792 and 1,000 can be reduced by 2 right away using divisibility by 2. Let's see, 792, 2 going to 6 3 times, that's 19. 2 going to 19, 9 times, that's 18. So that's 12, that's 6. Okay, 14. 9 plus 9. 9 plus 9. Okay, so I'm thinking divisibility by 3, but 3 cannot go into 1,000 evenly. So that's 396. I probably think 4 can go into 92 evenly. 1,000 divided by 2 is 500, so I can reduce it one more time by 2 again. So that's 54, that's 250, 396 divided by 2. Reduce them by 2 again. So that's 1, that's 9, that's 8. Oh, I can do it again. 198 over 250, reduce it again by 2. 198 divided by 2, that's 9, 18, that's 18, that's 9. So that's 99. All right. That's 99. So that's 54 and 99 over 250. Half of that is 125. So that's it. Okay. All right. 99 can be reduced by 9, 3, 11. 9. Maybe I can reduce by 9. Let's check it out. 125 divided by 9. Now, one time, that's 35. Nope, I thought it was 45, but it's not. All right, so that's my answer. 54 and 99 over 125. All right, just got to keep on reducing. So I reduced 2 twice. Okay, so that means I could have reduced it by 4, divisibility by 4. All right, let's read this one properly. 28 and 87 hundredths, because the 7 is on the hundredth. I know this one cannot be reduced because I know 87 can be reduced by 3. But 3 going to 87 one time. That's 2 times. That's 6. That's 27. So 3 going to 29. So this is actually 3 times 29. I know both 3 and 29 cannot reduce with 100. So I know this problem I cannot reduce 87 with 100. So that's my answer. All right. So when we are able to read our decimal number properly, we can quickly convert them into a proper fraction or convert them into a mixed number just by reading them. Okay. So once we write them as a fraction, we reduce, okay, to the simplest form. All right. That will conclude this lecture video. Thank you for watching.